I've just now started recording.
Awesome. Okay, kia ora tātou. So I'm Bronwyn Gibbs, and as Rachel said, I work for Massey University. I'm a mentor with the DIMIC team, which is developing mathematical inquiry communities. Prior to that role, I was a classroom teacher, so I was teaching from year 3 up to year 8. So this morning I'm going to be talking about my thesis, my master's thesis, which I recently submitted. So please do ask any questions. My children were giving me a hard time saying how exciting it was that I actually had a captive audience to tell all about my thesis, because I think they're a little tired of hearing about it. But it was really interesting and exciting work. So hopefully you'll learn something and have some good questions, so I can be learning something as well this morning. So just as a kind of overview of what we'll be covering, we'll just start with an introduction and where I was coming from with my research and why I wanted to look at this area. Then I'll talk about what I did, what my findings were, why these findings are important or why I think they're important, and then any questions at the end. But please do, if there are questions as we're going, just put them into the chat, and Rachel will yell out if there's anything she feels it would be good to cover at that time. So the reason for my thesis was really that national and international data shows that Māori and Pāsifika students are underachieving in all areas of mathematics. What I was particularly interested in was algebra, because Māori and Pāsifika students come from a background that is really rich with algebra. So if you think about geometric patterns that we see on marae, if you think about cultural patterns and mats and clothing, if you think about the patterns that there are in dance or kapahaka or drumming, there is algebra and growing patterns everywhere. Success in algebra really does play a major role in success beyond just the classroom. So algebra is often labelled as a gateway because it opens avenues for academic and professional success. By the same token, algebra is also a gatekeeper for students who aren't achieving in mathematics. So high failure rates in algebra exclude many students from equitable outcomes, and particularly in STEM subjects like science, technology and engineering. So for students to enter into engineering at university, they have to achieve well in NCEA algebra, but if they're cut off from even entering into that because they're streamed into internal mathematics, then they're actually being excluded from those opportunities. So achieving highly in maths and in algebra, particularly in high school, does have an effect on an ongoing effect in lifelong income and even health outcomes for Māori and Pāsifika peoples. So evidence suggests that this underachievement can be attributed to 3 factors. There are others, but these were the key ones that I found in my literature searches. Deficit theories. So deficit theories are when the blame for disparities in educational outcomes are attributed to students themselves and perceived deficiencies in their families, communities and cultural backgrounds. We hear things, and this is aside from my thesis, but in my role as a mentor, we hear things from teachers like, these children come to school knowing nothing. So children's cultural understandings and cultural mathematical understandings aren't being given a chance, and they're viewed through a deficit lens. Really related to that are pervasive views that mathematics is culture and value free and is just around universally accepted facts, rules and procedures. But we need to look at whose cultures are being privileged in the classroom. And a lot of the research that I was reading was talking about in Australia, Aboriginal students looking at mathematics as assimilation, that they had to become white in order to succeed in mathematics. Another issue around underachievement are structural inequities, which have always been in our education system, which are privileging certain groups of students, and other groups of students are disadvantaged. So really, I thought about a common thread between the 3 components is that they're all problematizing students' cultures. So what I wanted to do was explore how we could use students' cultures as strengths. And in particular, I wanted to investigate how culturally contextual tasks support Māori and Pāsifika students to represent and generalise functional relationships. I found that there wasn't a lot of research in this area, and generally when there is research on algebra, it's on decontextualised patterns, so just kind of geometric patterns, but nothing relating to any Māori or Pāsifika cultures. So what I did was a design-based research and using qualitative research methods. I worked with a group of year 6 to 8 Māori and Pāsifika students in a low socioeconomic urban school. It was an 8-lesson, I don't like the word intervention, but it was a series of 8 lessons that focused on growing patterns that were drawn from Māori and Pāsifika cultures. I did a pre-test and a post-test just to kind of see where their understandings were at. So this was just an example from the pre-test, lesson assessment that I did. I used a contextual task and a decontextual task just to see what they would do with it. So you can see here that their initial understandings were really based on quite concrete numerical thinking. What they tended to do, this was a Te Vai pattern, and what they tended to do was just count the number of leaves. So you can see they've counted 12, 20, 28, and figured out that the pattern was +8 each time. And so they're thinking about the recursive value, so it's just going up by 8. Interestingly, even at this stage, before we'd done any of the lessons, they were able to access the contextual task more readily than the decontextualised task. Often there was sort of no response or not the same sort of evidence of any understanding of the pattern growing. When it came to, I got all this data, and then when it came to kind of making sense of it, I started off looking at lesson by lesson, but actually that became was a little bit repetitive. So what I then started to do was look deeper at the data. And I looked at actually what were the strongest themes and trends that were coming through. One thing that was really evident from the students' responses to the tasks was their use of Tcharts, or also like a function table, so you know, the good old T. They were the most commonly used tool to make sense of and explore the functional relationships. And as the series of lessons went on, they were used in gradually more complex ways. So to start with, the kids really just used them to organise their data, and they were using them to notice patterns. But as the lessons went on, they were really using them in a lot more of a sophisticated way to compare the data and to find the functional relationships between the variables. This is just an example. This was the very first problem that we did, and well, I'll let you have a quick read of it. It was a low floor, high ceiling task in that everybody could access the task, but they could take it quite high if they wanted to. So they could have come up with 3x + 1 as the rule. They could have been graphing that relationship, or, you know, there was a lot of ways that they could take and show their thinking. What actually came out of it is all the groups pretty much came up with a T-chart, or they were calling this an H-chart because it more closely resembled an H. But you can see they're really looking at the recursive relationships. So they're going down the table. On the left is the sequence, 1, 2, 3, 4, 5, and then they've got the claps that they saw going +1, going up by 1, the slaps going up by 2, and the total going up by 3. So they were looking at the next step, but they weren't thinking about the functional relationship between the variables at this early stage. After a couple of lessons where that we could see that they were getting really, you know, they could really easily find that relationship, we wanted to see what would happen if we pushed them a little bit further. So we set up this lesson that was around the, you can see the rope pattern here. It's on the side of a waka at the local Tokelauan Hall. So a lot of kids were familiar with this, but they hadn't looked at it algebraically. And this problem was really the transition point away from that recursive thinking. So this time they'd set up their table, and this is the conversation that was going on. So one of the students said, we're timesing the pattern number by how many hoato. So that's the rope. So you could see down the side, they've written 6, 12, 18, 24. And in the middle bit, they're seeing it's going plus 6, plus 6, plus 6. So one of them said, wait, you're always adding 1. Unless you want to times the pattern and take away 1. So you can see they're starting to look at a T-chart as the way to find the relationship between the variables. And then someone else has said, so instead of going down the T-chart, you've gone across. So the teacher and I were, pretty happy that this was happening now. So this was around about the third problem. Then they started to use the T-chart to generate a rule. So this was in a couple of problems later. And you can see what they're doing here is they've got the sequence, the pattern number, and then they've made another column for the rule. And what they did is this actually became a common and shared classroom practice, that they decided that what they could do is use the T-chart. They could see what it was going up by, like +6 each time, rather than going +6, +6, +6, they could multiply by 6 and then add or subtract the difference. So they were generalizing finding the common difference between the successive values and then adding or subtracting what they needed to. So that was actually pretty clever. And all of this was coming from the students themselves. By the end of the sequence of lessons, they were able to use the T-chart to find the quadratic relationships. So what they were doing is identifying the most important property of quadratic functions, that the second difference in the values have the common difference. So you can see that they've got +3, +5, +7, +9. So that was the first difference, but the second difference is the consistent +2, +2, +2. So they were really using these T-charts to support their reasoning about the functional relationships between variables. So hopefully that shows you the transition from those early days of just kind of recording their thinking to actually using the T-chart as a tool. So that was one way that they were using representations to support generalization. Another way that they represented their thinking was visually, and they would draw to help them to identify the structure of the contextual patterns and to make sense of the relationship between the variables. So you can see in this one that engaging with it's a ngātu or tapacloth, engaging with it visually gave them the opportunity to see the multiplicative structure. So they could see that each of the stems they could multiply by 8 and then add 4, which was the constant in the middle. And this aligned with the research that showed that visual strategies are really powerful for generalizing functional relationships instead of just using numerical strategies alone. Again, they became more sophisticated with the way that they used visual representations. So in this case, they were using a visual representation to justify their rule. So you can see down the bottom here, S times 6 plus 3 will give you the number of boxes in the pattern. And one of the students has described what they've done visually, saying that S is the pattern number, and the 3 is from you can see the row of 3 up the top, and then the 6 they're timesing is the 6 square boxes below. So see how every pattern has an odd line. They all just have one row of 3 you have to add on up the top. So they're using the visual pattern alongside the numerical to justify the generalization. And again, going up into triangular numbers or a quadratic relationship, they used a visual representation to turn the triangular pattern into they've said a square, but it's rectangular. No, it's not. Oh, rectangular, yeah, it is. And supported them to find the relationship here, which was really tricky. And it was really exciting to see what they did with that. So again, the visual representations were really powerful, much like the T-charts, to support them to bridge the gap between the concrete and the tasks and the more abstract mathematical structures underlying those growing patterns. Also, natural language around these familiar cultural contexts was a way of expressing generalizations. Throughout the tasks, I integrated Māori and Pāsifika languages in terms of sometimes with the numbers or the context, what was happening in the problem. The students were really encouraged to draw on their home languages as part of the mathematical discussion. So you can see one of the participants down the bottom said, sometimes if my Samoan friends are struggling to speak English, we speak Samoan to help them, so we all understand stuff. So that was a part of it, was using home languages, but what the literature shows is that natural language to express generalizations has a really important role in developing algebraic thinking, because it allows the learners to make sense of and describe the algebraic concepts using language that they know. So you can see here the transition in terms of how their algebraic understanding grew. So with that recursive thinking, for the slaps it adds on 2, it goes +2, +2, +2, is 2, 4, 6, 8, 10. You can see that they're sort of still relying on really concrete thinking, and it's just +2, +2, +2, but there's no generalization there. It's just looking recursively. The second one, the covariational thinking, every time you move to the next pattern, the leaves grow by 8 and the stems stay at 4. So they're not thinking about concrete numbers, but they are still talking about particular points in the pattern. So you wouldn't be able to find the 100th there, because it's just every time you move to the next pattern. But the final one with the correspondence thinking is when students were really aware of that correlation between the variables and describing a generalized relationship. So if you times the rod with the crosses, then take away 6, that tells you how many crosses there are. So they're thinking here really generally about the pattern and how you can use that functional relationship. This really actually naturally led to them spontaneously using some symbols or symbolic representation to represent the rule. They started using a mix of natural language and symbols because they just wanted to kind of hurry it up. So they were saying things like, we started to shorten it by just writing the first letter to L, which is the L for leaves, and the first letter for pattern, which is P. So 8L times P plus 4. So they're really speeding it up, but they're using some quite sophisticated thinking there as well by using symbols to represent the variables. What happened too is that they were expressing them the generalization in their own language and symbolic language, or a combination of the two. But once they got to the last problems, which were a lot harder, they used what was called symbolic advantage, and it was actually easier for them to represent it using symbols than it was to write the whole generalization as a rule in natural language. So you can see here, they've got P times 24 plus 4, which was a lot easier than going through the whole, you always times the position by 24, then you add 4, da da da. So yeah, it was cool to see that as the problems got more complex, the students were more successful representing the functions in symbols than they were in words. So as well as each group kind of approaching the problem in different ways, the teacher was really getting them to look at the multiple representations and to share how the different groups had solved the problem and look for connections between these different ways and different kind of layers of sophistication of looking at the generalization. So this was at the end of one of the lessons, and you can see that the teachers got a group to share how they solved the problem with the Tcharts, then the next one, how they solved it visually, and then the next one, how they've solved it using variables and an equation. So the kids were able to look for what was the same and what was different in here. And they could see that they could make connections between the different ways of representing the same function. Then they started to do that independently in their books. So they, this I know that's a little harder to see, but they were trying to use each of these different ways of representing the problem. So you can see here they've got like a visual representation, they've got a Tcharts, they've written out the rule in natural language, and they're trying to find a way to symbolically represent it as well. So it was quite amazing shifts when you think back to the beginning, where they were really just counting the number of leaves in that growing pattern. this was just a quote from a student, but what it was showing is that they recognised when they used multiple representations to solve a task, they could check their reasoning because they arrived at the same conclusion in different ways. So it showed that they were really digging into the structure of these patterns and how they were growing. I'll give you a moment just to read that. Cool, okay, so that was kind of the mathematical growth that happened in terms of the sophistication in generalising and in representing the growing patterns. Alongside that, the kids really developed their strong cultural identities as well as their mathematical identities. So what happened is that I did interviews after each lesson and at the end of the series of lessons and asked the students, like, how did it feel being Māori doing maths? And they felt that their cultures were just normalised. So quotes like, it feels the same, I just feel like I'm Māori. So there was that strong cultural alignment between their lives outside of school and their lives within the classroom. Other students expressed real feelings of belonging when the tasks were centred around their cultures and lives. And this student said, it makes me feel welcomed. It makes me feel like I belong here. And I think as educators, that's what we all want for students, is to feel like they have that sense of whānau and that sense of belonging in the classroom. So it was really positive to hear these sorts of statements from the students. Another strong theme that came through was the feelings of pride in having their cultures represented in their cultural heritage, which made them consider their families were good mathematicians. I really like the quote down the bottom. It was a little boy who didn't actually say so much, but when I interviewed him, he started talking about the things that his grandma makes and how the patterns grow. She has to remember it, how it's going up, what the pattern is, how long it needs to be. My ancestors used algebra way before me. And they talked about, you know, they were just blown away at how clever their families were and their ancestors were through understanding and knowing algebra. And the quote above, feeling proud about having their culture in the problem and represented in the problem. I just put this in because this wasn't an interview, I overheard it when these kids were talking after the lesson. And they were comparing here about, the problem had been about this dance skirt, a titi. And they were saying, oh, it's the same in the Cook Islands. What about Samoa? We have our lava lava. And they were having this discussion. Then it finished off with a boy saying, all the Islander nanas make fans, because they were kind of trying to out-compete with each other about whose family was the best at making stuff. And also they're making connections between each other's cultures and commonalities. So it was, really cool to have them sharing cultural expertise and their cultural knowledge with each other. Then we looked at the developing mathematical identities alongside their growing cultural knowledge, and being positioned as experts resulted in this increased confidence and feelings of empowerment as learners and doers of mathematics. So this student was saying, I never knew how to do algebra. I thought it was really tricky, but this was the key point. When it involves our culture, once you hear it's something about your culture, you're like the expert because you know a lot of things. And you're like, oh, yep, this is me, I know it. And then you relax and have fun. It gives you confidence and it gets your brain working. So the culturally located tasks really gave the students opportunities to draw on the mathematics embedded in their cultures and resulted in increased confidence as mathematicians. So the key findings that came out were, around when Māori and Pāsifika students were given opportunities to draw on their cultures to make sense of functional relationships, they constructed increasingly sophisticated and abstract representations to identify, communicate, and justify generalisations. There was significant growth, and this was really interesting, in their conceptual understanding of both the contextualised and decontextualised growing patterns. So in that first assessment task, they were much more confident with the contextual pattern, but by the post-assessment, they were equally as confident with the contextual pattern and decontextualized pattern. So I found that really interesting. So you can see the difference between that initial assessment when they were just counting the leaves to this one, and this was the decontextualized task because it's just the dots you can see around the outside, but she was able to represent this in multiple ways and generalize the relationship. So, as I said earlier, aligning tasks with Māori and Pāsifika students' traditions, cultures and experiences strengthen both their mathematical and cultural identities. So this is really important because it contradicts Māori and Pāsifika students' performance on national and international measures of mathematics and achievement. So throughout this research, the culturally contextual tasks really did act as a lever for equity by blurring that line between cultural knowledge and content knowledge, and gave opportunities for students to engage in high-level algebraic reasoning because it was their cultural capital that was being privileged in the classroom. So I think that really overall, recognising that mathematics is inherently cultural is a key equity issue for students who have traditionally been marginalised in mathematics. So when we can align problems with Māori and Pāsifika students' traditions, experiences, beliefs, worldviews, it really provides opportunities for those students to be positioned as experts, to make connections to the maths, and to strengthen both their cultural and mathematical identities. So that's a race through my thesis. And what I'll do now is just check if there are any questions or anything that you want to discuss further. So Rachel, was there anything there?
Yeah, there's a couple. There's one from Claire. Do you want to do your question yourself, Claire? If so, just unmute yourself and ask Bronwyn your question.
Yeah, so my question is that in our classrooms, we have a huge variety of students from different cultures and areas of the world. And so when you give the questions to the class, do you give it to them as different questions all at the same time so that you have something for everybody's culture? Or do you focus on one culture at a time and the whole class addresses that?
Yeah, cool. That's a really good question, Claire. Thanks for asking that. No, just one problem at a time. I was really focused on Māori and Pāsifika learners, and the schools where I mostly work, Māori and Pāsifika learners are a big part of the role. In fact, 100% at most of the schools. But you know, there is a lot of diversity in a lot of schools throughout New Zealand. So what I suggest doing is thinking about everybody's cultures. You're not going to have a whole lot of different problems on one day. Just have the one problem, but just be aware of being really inclusive. So you may have a problem that's really focused on a school that I was working in recently had a large number of Syrian refugees. So you might be looking at a context that's focused on their cultural lives. What was the other part of the question? So it was, oh, no, sorry, I've got back my train of thought there. The other thing that the teacher did too is when she gave the problem to the students to be working on, she spent quite a lot of time really unpacking that problem and getting the students to share their cultural expertise. So when she had a problem that was around kapa haka, she had the Māori students that frequently perform and participate in kapa haka sharing their experiences. So you could be doing the same with students that people may not know about their cultures, and it's an opportunity for everybody to learn something new and for them to, you know, kind of be uplifted and really acknowledged as their cultures are important. So hopefully that answers your question.
And we had another question from Christine. Do you want to ask your question, Christine? No, it was just she wanted to get copies of the activities given in the presentation so that she could use them with her students.
Yeah, sure. My email is on the beginning, but my email is just BE.Gibbs, so it's BEGIBBS @massey.ac.nz. So just email me and I'll send the problems out to you.
Can I ask one question?
Yeah.
Very interesting presentation, Bronwyn. It's yeah, using culturally relevant activities is really very powerful, especially when, you know, I've used some tuku patterns, especially the Potama patterns, and when you bring a weave into the classroom, the students sit up and they say, oh, my grandma used to weave something like that, and there's a lot of interest and motivation. One other thing that I found that was useful, the Tcharts is very powerful, is to have another column for students to see how they view the pattern and how they are, what is their method of counting, and have that, you know, the sharing with the rest of the class so they can see how the different students have, you know, actually counted, and you will arrive at the same generalization, although it looks different. So for example, something like 4 brackets n minus 1, and it could be 4n minus 4. That's the way some students would have counted. And to have another column, you know, is to see how they have counted and use the 5 practices, you know, that pedagogy where,
Yeah.
and use that in tandem with, you know, with this kind of activity is really very powerful. So I'm still exploring that a lot more. What I tend to do sometimes is to have those patterns on the left-hand side, and you have the pattern number, like you have the pattern number 1, 2, 3, 4, 8, and then you have the dots or the leaves, the next one, and then how they see the pattern and how they want to, then what's the relationship between the pattern number and the dots or the leaves in the next column. So I found that sort of helps them. I'm still exploring that a lot more. I didn't use that before, but I've started to use that now, and I find that really powerful, and especially using it the way you have done with the the cloth patterns and the leaves patterns, both with Māori and Pāsifika, is really, really very powerful.
Oh, that's awesome. I'm really excited that you're doing that in your class, because I think that, like, A, it's so much fun as a teacher, and B, there's so much learning for the students. I just flicked back to this slide with that multiple representation. So the teacher really taught, you know, well, she's a DMIC teacher, but it is really aligned with the 5 practices. So these were 3 separate groups sharing how they had seen the pattern growing. And then, yeah, like you're saying, looking for the relationships between them, like what's the same here and what's different here. So I think, you know, that it's just such a powerful way of learning compared to the old way when it would be like, I'm going to teach you how to generalize a pattern and find a rule. You just do it like this. So this is really building such solid conceptual understanding and based on what's important to students in our classes. So I'm really excited for you that you're doing that, and thank you for your comment.
Yeah, thank you.
Anything else?
Any other? There's lots of really positive comments in the chat line, Bronwyn. All things like saying really powerful and very cool.
Oh, good. I like that one. Whoever said that one, that's a good one.
And just mentioning that your love of students really shines through, and their love of maths.
Oh, that's fantastic. Thank you. So as I did give my email, so if anyone wants any support or ideas or you know, just want to have a chat or anything, just do feel free to email me, because it is my passion, and I really do love to help other educators to be able to teach all our students in ways that acknowledges them as cultural beings and really supports them to grow as mathematicians and as people. So anything I can do, just yell out.
Yeah, it'll be great to read your thesis, Bronwyn. Is that available online, or do we email you, or is there a synopsis available?
Yeah, it's still being marked at the moment because it's not actually that long ago that I submitted it. So once it is, then it will be available, which I don't know when that will be, but when it is, even if you email me and I could put a note in my calendar and let you know when it is and send it to you.
Sure. Thank you.
Thank you. All right. Any final requests?
I'm just seeing if there are any last questions coming in. Yeah, just thank you for giving people some great ideas. Thanks for being so available. Yeah, just lots of thank yous, I think.
Awesome. Oh, well, thank everyone too. Thank you for attending on a Saturday morning.
Yeah, thanks everyone for attending. So we'll just
so I'll stop my share, eh?
Yeah, so I've just gone back to this one.
Oh yeah, cool.
And just a couple of reminders that we have got end of year, if you're in Auckland, the end of year statistics day on the 30th of November and the end of year maths day on the 1st of December. So those are two big days coming up. They are going to be in-person days hosted at Auckland University unless alert level changes, in which case we will rapidly switch to an online mode. And here's the link for feedback on today's presentations. We'd love to hear from you, and in particular we love to hear any ideas for future sessions. If there's any sort of area that you're really looking for a bit of professional development on, then just drop us a line in that feedback, and that would be really handy. The videos will all be posted on the AMA website, but it does take a little bit of time to just process those videos and get them up onto the website, but they will be there in the not too distant future. So I think it just leaves me to say thank you so much, Bronwyn, for sharing your thesis work, and well done on submitting that thesis, and hopefully you get the marks back soon. And thank you everyone who has attended this session this morning. Great to see so many of you here on a Saturday morning, and we hope that lots more people will watch Bronwyn's presentation in their own time who've registered for this session as well. So unless there's any further questions, I think we will close this session.
Awesome. Thank you so much, everybody.
Bye.
Thank you, everyone. Thank you.
Bye. Thank you. Rachel, is there anything else, or will I just